Most generators up to 17.5 kilowatts and other brands require a model-matched transfer switch that mates directly with the generator. It is also Underwriters Laboratories or all listed for that particular generator model. These transfer switches sense power from the generator. Then they interrupt the utility feed to the house and connect the generator to the house wiring. On some models, the transfer switch is hardwired to the generator, while on others, there is a male plug with a male cord connecting the generator to the transfer switch. There is a model-matched transfer switch that interfaces directly with the generator and is UL tested and listed for that particular generator. The transfer switch does not feed the entire panel. Instead, a generator subpanel is installed to feed essential circuits or hardwire some appliances directly to the generator transfer switch. Therefore, appliances and circuits should be carefully evaluated to determine which circuits are essential during a power outage. In this way, the generator will not be overloaded by drawing too much current, as each generator has a fixed power output rating. The generator subpanel will have only a few circuits from the house, only essential circuits. The house panel then provides power to the rest of the home. The National Electrical Code, or NEC, requires that the generator subpanel be secured with a lock to prevent someone from inadvertently connecting the generator to the house wiring when utility power is present, since this could be fatal to utility workers repairing power lines. If the generator is hardwired to essential appliances, these appliances must be fused or circuit breaker protected at the generator transfer switch for overcurrent protection, and wiring to the appliances must be rated for the current draw of the appliances. On larger generators ranging from 20 kilowatts and up, a whole house or critical load transfer switch is used. This transfer switch has a higher ampacity design and can either feed selected circuits or the entire house, depending on the size of the transfer switch and its rated ampacity. In this case, the transfer switch is installed between the main house feed and the main house panel and is designed to carry the load of selected circuits or the entire house, if the transfer switch is sized properly to handle the load. The type of transfer switch used is dependent on the generator output power rating and the specific needs. NEC Code requirements must always be followed for the safety of the homeowner and utility personnel. Considering the technical aspects, it's important to delve deeper into how these transfer switches function and the safety measures involved. Firstly, let's clarify the role of the transfer switch. It acts as an intermediary device that safely disconnects the utility power and connects the generator to your home's electrical system. This prevents backfeeding, where the generator's power flows back into the utility grid, which is extremely dangerous for utility workers. Secondly, let's discuss the different types of transfer switches. There are manual transfer switches and automatic transfer switches. A manual transfer switch requires you to physically switch the power source, while an automatic transfer switch detects a power outage and automatically switches to generator power. For smaller generators, essential circuit transfer switches are common. These switches are connected to a subpanel that powers only essential circuits such as lights, refrigerators, and medical equipment. This is a cost-effective solution, as it doesn't require a large generator to power the entire house. For larger generators, whole house transfer switches are available. These switches can handle the entire load of your home, but they require a larger generator and a transfer switch with a higher ampacity rating. Thirdly, let's discuss the importance of NEC Code compliance. The NEC sets the standards for safe electrical installations. It's crucial to follow these standards when installing a generator and transfer switch to prevent electrical hazards such as fires and shocks. Some key NEC requirements include proper grounding, overcurrent protection, and wiring methods. Grounding ensures that electrical faults are safely directed to the ground, preventing electrical shocks. Overcurrent protection, such as fuses and circuit breakers, protects the wiring from overheating and causing fires. Proper wiring methods ensure that the wires are sized correctly for the load and are installed in a safe manner. The selection of a transfer switch is a critical decision that depends on several factors. 1. The size of your generator, and 2. The amount of power you need to supply during an outage. Smaller generators are typically paired with essential circuit transfer switches, while larger generators can be used with whole house transfer switches. Remember, it's always recommended to consult with a qualified electrician to determine the best solution for your specific needs and to ensure that the installation meets all applicable codes and regulations. Proper installation of a generator and transfer switch involves several steps. Firstly, the electrician will determine the location of the generator and transfer switch. The generator should be placed in a well-ventilated area away from combustible materials. The transfer switch should be installed near the main electrical panel. Secondly, the electrician will install the wiring between the generator, transfer switch, and electrical panel. The wiring must be sized correctly for the load and must be installed in accordance with NEC Code. Thirdly, the electrician will connect the transfer switch to the main electrical panel and the generator. This involves disconnecting the utility power and connecting the generator power. Fourthly, the electrician will test the system to ensure that it is functioning properly. This includes verifying that the transfer switch is switching between utility power and generator power correctly and that all essential circuits are being powered by the generator. Maintenance of a generator and transfer switch is also important for ensuring reliable operation. The generator should be serviced regularly according to the manufacturer's recommendations. This includes changing the oil, replacing the air filter, and checking the spark plugs. The transfer switch should be inspected periodically for any signs of damage or corrosion. If any problems are found, they should be repaired immediately by a qualified electrician. Understanding the specific generator subpanel requirements is crucial for safety and compliance. The generator subpanel is a separate panel that is dedicated to powering essential circuits during a power outage. The NEC requires that the generator subpanel be secured with a lock to prevent someone from accidentally connecting the generator to the house wiring when utility power is present. This is to protect utility workers from backfeeding. The generator subpanel should also be clearly labeled to indicate that it is powered by a generator. This helps to prevent confusion during a power outage. The circuits that are connected to the generator subpanel should be carefully selected based on the homeowner's needs. Essential circuits such as lights, refrigerators, and medical equipment should be prioritized. The total load of the essential circuit should not exceed the capacity of the generator. Wiring considerations for the generator and transfer switch are also important. The wiring must be sized correctly for the load and must be installed in accordance with NEC Code. The wiring should also be protected from physical damage. Conduit is often used to protect the wiring from damage. The wiring connections must be secure and properly insulated to prevent electrical hazards. When selecting a transfer switch, it's important to consider the ampacity rating of the switch. The ampacity rating is the maximum amount of current that the switch can safely handle. The transfer switch should have an ampacity rating that is equal to or greater than the load that will be connected to it. It's also important to consider the voltage rating of the transfer switch. The transfer switch should have a voltage rating that is compatible with the voltage of the electrical system. Most homes in the United States have a 240/120 volts electrical system. The physical size of the home feed lines can be a challenge when installing a transfer switch. The home feed lines are the wires that connect the utility power to the main electrical panel. These wires can be quite large, especially in homes with a high electrical load. Some transfer switches may not be large enough to accommodate these large wires. In this case, it may be necessary to use a larger transfer switch or to modify the wiring to reduce the size of the wires. It's also important to ensure that the transfer switch is properly grounded. Grounding provides a path for electrical faults to safely flow to the ground, preventing electrical shocks. The grounding wire should be connected to a grounding electrode, such as a ground rod or a metal water pipe. Understanding the relationship between generator size and transfer switch ampacity is key to a safe and efficient installation. The generator's power output, measured in kilowatts, determines the amount of current it can supply. The transfer switch must have an ampacity rating that is sufficient to handle the generator's output current. For example, A 10 kilowatt generator can supply approximately 41.7 amps at 240 volts. The transfer switch should have an ampacity rating of at least 50 amps to safely handle this load. It's always better to choose a transfer switch with a slightly higher ampacity rating than is strictly necessary to provide a safety margin. This can help to prevent the transfer switch from overheating or failing under heavy loads. When selecting a generator and transfer switch, it's important to consider the long-term needs of the homeowner. As the homeowner's electrical needs change, the generator and transfer switch may need to be upgraded. It's always better to choose a generator and transfer switch that are slightly larger than is currently necessary to allow for future expansion. This can save the homeowner money in the long run by avoiding the need to replace the generator and transfer switch in the future. The NEC provides specific guidelines for sizing generators and transfer switches. These guidelines are based on the total load that will be connected to the generator. The NEC also provides guidelines for the installation of generators and transfer switches. These guidelines are designed to ensure that the installation is safe and compliant with all applicable codes and regulations. It's always recommended to consult with a qualified electrician to determine the best solution for your specific needs and to ensure that the installation meets all applicable codes and regulations. Understanding the different types of transfer switches is crucial for selecting the right one for your needs. Manual transfer switches require the homeowner to manually switch between utility power and generator power. Automatic transfer switches automatically switch between utility power and generator power when a power outage is detected. Manual transfer switches are less expensive than automatic transfer switches, but they require the homeowner to be present to switch between power sources. Automatic transfer switches are more expensive, but they provide a more convenient and reliable solution. Some transfer switches also include load management features. Load management features allow the homeowner to prioritize which circuits are powered by the generator. This can help to prevent a generator from being overloaded. For example, the homeowner may choose to prioritize essential circuits such as lights, refrigerators, and medical equipment. The NEC requires that all generators and transfer switches be properly labeled. The labeling should include the manufacturer's name, the model number, the serial number, and the ampacity rating. The labeling should also include a warning that the generator should only be operated by qualified personnel. NEC also requires that all generators and transfer switches be inspected and maintained regularly. The inspection and maintenance should be performed by qualified personnel. The inspection should include a visual inspection of the generator and transfer switch, as well as a functional test to ensure that they are operating properly. The maintenance should include cleaning the generator and transfer switch, lubricating moving parts, and replacing worn parts. Understanding the potential hazards associated with generators and transfer switches is crucial for ensuring safety. Generators produce carbon monoxide, a deadly gas. Generators should only be operated in well-ventilated areas. Transfer switches can create a backfeeding hazard if they are not properly installed. Backfeeding occurs when the generator's power flows back into the utility grid, which can be dangerous for utility workers. It's always recommended to consult with a qualified electrician to determine the best solution for your specific needs and to ensure that the installation meets all applicable codes and regulations. Before operating a generator, it's important to read and understand the manufacturer's instructions. The manufacturer's instructions will provide important information about the safe operation of the generator. It's also important to follow all safety precautions when operating a generator. These precautions include wearing appropriate personal protective equipment such as gloves and safety glasses. Generators should never be operated in wet conditions. Wet conditions can create an electrical shock hazard. Generators should never be operated near flammable materials. Flammable materials can ignite and cause a fire. It's also important to ensure that the generator is properly grounded. Grounding provides a path for electrical faults to safely flow to the ground, preventing electrical shocks. Never attempt to repair a generator or transfer switch yourself. Repairs should only be performed by qualified personnel. Incorrect repairs can create a safety hazard. When disconnecting a generator from the transfer switch, it's important to follow the proper procedures. The proper procedures will vary depending on the type of transfer switch. It's important to consult the manufacturer's instructions for the specific transfer switch. In general, the first step is to turn off the generator. The second step is to disconnect the generator from the transfer switch. The third step is to turn off the transfer switch. The fourth step is to reconnect the utility power. Understanding the National Electrical Code, or NEC, requirements for generators and transfer switches is crucial for ensuring a safe and compliant installation. The NEC is a set of standards for safe electrical installations. It's important to follow these standards when installing a generator and transfer switch to prevent electrical hazards such as fires and shocks. The NEC provides specific guidelines for sizing generators and transfer switches, installing generators and transfer switches, grounding generators and transfer switches, and labeling generators and transfer switches. The NEC also requires that all generators and transfer switches be inspected and maintained regularly. The NEC is updated every 3 years. It's important to stay up to date on the latest NEC requirements to ensure that your installation is compliant. The NEC is available for purchase from the National Fire Protection Association, or NFPA. The NFPA also offers training courses on the NEC. In addition to the NEC, there may be other local codes and regulations that apply to generators and transfer switches. It's important to check with your local building department to determine what codes and regulations apply in your area. Understanding the different types of generator fuel is also important. Generators can be powered by gasoline, diesel, propane, or natural gas. Each type of fuel has its own advantages and disadvantages. Gasoline is the most common type of generator fuel. Gasoline generators are relatively inexpensive and easy to operate. However, gasoline is also highly flammable and can be dangerous to store. Diesel generators are more expensive than gasoline generators, but they are more fuel efficient and more durable. Diesel is also less flammable than gasoline. Propane generators are a good option for homeowners who have access to a propane tank. Propane is a clean burning fuel and is relatively safe to store. Natural gas generators are a good option for homeowners who have access to a natural gas line. Natural gas is a clean burning fuel and is relatively inexpensive. However, natural gas generators require a permanent connection to a natural gas line. When selecting a generator, it's important to consider the type of fuel that is available and the cost of the fuel. It's also important to consider the environmental impact of the fuel.